Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a fascinating project, enhancing MIDI hardware using Perl. It's all about pushing the boundaries of what your MIDI keyboard can do. Exciting stuff!
I'm really keen to hear this. So, the core idea is to use Perl to create a software MIDI filter, right? To add features not present in the hardware itself?
Exactly. The author uses an M-Audio Oxygen Pro 61 as an example, but the principles apply broadly. The limitations of even fairly advanced MIDI hardware are addressed by creating a Perl-based MIDI proxy. This proxy intercepts MIDI messages, processes them, and then sends modified or augmented messages on. Ingenious!
So what kind of features are we talking about? Give me the highlights.
Well, there are two main features showcased: a pedal tone effect and a controller bank system. The pedal tone adds a sustained bass note and its fifth to any note played, creating richer harmonies. Think of it as instantly creating a three-note chord from a single key press. It's implemented using clever MIDI message manipulation within the Perl script.
That sounds pretty cool. And the controller banks?
The controller banks let you switch MIDI channels using the pads on the keyboard. Each pad selects a different channel, effectively giving you 16 different banks. This is much more intuitive than the keyboard's built-in bank system. Plus, it extends the functionality beyond the 4 banks the hardware provides.
So it's not just about adding effects, it's about improving the workflow and usability of the hardware too. Clever?
Precisely. And the author even goes further, adding a strum effect to the pedal tone, introducing a slight delay between the notes of the chord. This adds a more expressive, almost strummed quality to the sound. It's a great example of how you can use the asynchronous capabilities of Perl to achieve this kind of timing control.
I'm curious about the implementation details. How does the Perl code actually achieve all this? Is it complex?
The code uses the Art MIDI library, which provides a way to interact with MIDI devices. The core is a MIDI filter class that sets up an event loop and manages MIDI input and output. It uses callbacks to process incoming MIDI events. Each callback can modify the event or create new ones, and they can be chained together to create complex effects. It's elegant, really. The author provides a complete gist with the source code, so you can check it out yourself.
I see. So each MIDI event triggers a callback, and these callbacks can modify the event or create new ones. It's like a pipeline for MIDI data. But what about latency? Doesn't adding this layer of processing introduce significant delay?
That's a great question. The author mentions that previous experiments showed minimal latency, a fraction of a millisecond. This is thanks to the asynchronous nature of the Perl code and the efficient RT-MIDI library. So, it's practically real-time processing.
Interesting. So what are the limitations? Are there any downsides to this approach?
Well, the author points out a potential issue with the bank switching feature. The simple implementation doesn't handle pickup, a feature where control changes only take effect if they exceed the previous value. This could lead to unexpected jumps in control values when switching banks. It's a minor limitation, but something to keep in mind.
Got it. So overall, this is a really impressive project. It shows how you can leverage programming to significantly enhance the capabilities of relatively inexpensive MIDI hardware. It's a testament to the power of open-source tools and creative problem-solving.
Absolutely. It's a fantastic example of how software can extend and improve hardware functionality. And the best part, the code is available so you can adapt it to your own MIDI controller and create your own custom effects. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the world of Perl and MIDI. Goodbye.
Bye-bye.